Hello, friends. A very warm welcome to the discussion of another topic pertaining to CSAT examination. And today's topic is number system, a very important topic from the point of view of quantitative ability. Now, this forms the very basis of arithmetic, and we are going to begin with the root basics. And then we will look at the variety of questions that are asked from this particular area. Now, first of all, let us know about numbers. First, we will talk about two categories of numbers, rational numbers and irrational numbers. Now, any number which can be expressed in the form of p by q, where q is not equal to 0. So, this will include integers, decimals, fractions. Now, these all are rational numbers. Then, what are irrational numbers? Now we can say that irrational numbers are those numbers which cannot be expressed in p by q form. Like we have certain numbers or symbols like pi or exponential or square root 2, any square root for that matter, which is not the square root of a perfect square. Now, what is an integer? Now, firstly, an integer is represented by the letter Z, as you can see here. The complete numbers in counting, positive or negative. Now, we know that there is something called a number line. If this is where 0 is, this shall be 1, 2, 3, 4, and so on. And less than 0, we have numbers like -1, -2, -3, -4. So these are counting numbers 1, 2, 3, 4, or 0, or even -1, -2, -3, -4. So as to say, there are different types of integers. So let us first of all talk about positive integers. Again, it is denoted by Z plus. Now, positive integers are the ones which are greater than 0. The counting numbers starting from 1, 2, 3 up to infinity. Now, similarly, we have negative integers which are less than 0, denoted by Z minus. These are integers which are less than 0, for example, -1, -2, -3, and so on. Now, there is another kind of an integer which is called a neutral integer. So, 0 is neither positive nor negative, hence, it is the only neutral integer. Now, the types of positive integers. First, we have natural numbers denoted by n. All the positive counting numbers starting from 1, 1, 2, 3, 4 up to infinity. Now, in natural numbers, we have even numbers, the numbers which are divisible by 2, 2, 4, 6, 8, 10, etc. And odd numbers, numbers which are not divisible by 2. That is 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, etc. Then what are whole numbers? Now 0, when followed by natural numbers, together form the set of whole numbers. So if we write the series of whole numbers, we shall start with 0, then followed by 1, 2, 3, 4, which are natural numbers. So 0 followed by natural numbers is actually the whole numbers. It is denoted by W. Then we have prime numbers. Now, if you have already watched the video for number series, there also we have discussed about prime numbers. And if you haven't, then this is a recap for you. Prime numbers are those numbers which have exactly two factors. Which ones? Itself and the digit 1. For example, 2, 3, 5, 7, 11, etc. All these numbers have only two factors, itself, the number itself, and the number 1. They are not divisible by any other number apart from themselves and number 1. Then what are composite numbers? Composite numbers are those which have at least 3 factors. Now, prime numbers have exactly 2 factors, and more than 2 that is, at least 3 factors will be there for the composite numbers. So these are 4, 6, 8, 9, 10, 12, 14, 16, 25, 18, 36, 106. Now, by the way, apart from 2, every other number is a composite number because 2 is the only even prime number, except 2, all the other prime numbers are odd numbers. Now, one thing that you must note here is that number 1 is neither prime nor composite. Many a times this question has been asked in interviews of various examinations also, that why is it that number 1 is neither prime nor composite? By the definition of a prime number, it has 2 factors, whereas a composite number has at least 3 factors, and 1 has only 1 factor, that is itself. So by definition of prime numbers and composite numbers, we can say that number 1 does not fit into any of these 2. Hence, 1 is neither prime nor composite number. So let us talk about prime numbers now. 1 to 50, there are 15 prime numbers. Well, as I said, 2 is the smallest and the only even prime number. As you can see, apart from 2, there cannot be any other even number which will become a prime number. Why? Because any other number apart from 2, let us take an example of another even number, let us say 64. It is divisible by itself, it is divisible by 1. Apart from that, it has so many other factors, 2, 4, 8, 16, then 32. So hence, it cannot be a prime number, it's a composite number. Now, starting from 1 to 50, there are 15 prime numbers which are 2, 3, 5, 7, 11, 13, 17 and 19, 23, 29, 31, 37, 41, 43 and 47. Whereas from 51 to 100, there are 10 prime numbers, and these are 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Now please know this, that 97 happens to be the only prime number in the 90s. Now some of you might have a doubt that what about 91? Is it a prime number? Well, kindly remember, and it will be useful for you in certain questions also, that 91 is 13 into 7. So hence it has more than 2 factors. 91 is a composite number. So when we find that 1 to 50 we have 15 prime numbers, 51 to 100 we have 10 prime numbers. So in total from 1 to 100 there are 25 prime numbers. Now you must memorize these 25 prime numbers because they will be of huge importance when it comes to solving questions based on number series and even in number system. Now we saw that from 1 to 100 there are 25 prime numbers. Now kindly know that from 101 to 200 there are 21 prime numbers, and somehow you need to remember them. Now these are the numbers which are there in front of you. Now how to find out whether a given number is a prime number or not between 101 to 200? Well, that is exactly where divisibility rules will also come into play. Now first, let us write down all the odd numbers from 101 to 200, because 2 is the only even prime number, which means that all the prime numbers from 101 to 200 shall be odd numbers only. So there are 50 odd numbers and 50 even numbers. So even numbers we will eliminate. Now out of these 50 odd numbers, we will eliminate the 10 multiples of 5, which are those 105, 115, 125, 135, 145, 155, 165, 175, 185, 195. We have eliminated them. Now let us have a look at the remaining numbers. So we have 101, 103, 107, 109, then 111, 113, 117, 119, then 121, 123, 127, 129, 131, 133, 137, 139, 141, 143, 147, 149, 151, 153, 157, 159, 161, 163, 167, 169, 171, 173, 177, 179, 181, 183, 187, 189, then 191, 193, 197, 199. Now these are the 40 odd numbers apart from the other 10 odd numbers which are divisible by 5. So we have eliminated 10, now we are left with 40, and you have to find out these 21 prime numbers. Now the process is quite simple. There are 8 prime numbers that you can memorize offhand. The first 4 numbers here are prime numbers: 101, 103, 107, 109. And the last 4 odd numbers here, 191, 193, 197 and 199 are also prime numbers. So 8 done out of 21, 13 more remaining. Now also we will cancel the squares. 121 is 11 square. 169 is also 13 square. So out of 40 we have found out 8 prime numbers and we have eliminated 2 squares. So out of 40 minus 2, 38 odd numbers, we have found out 8 prime numbers. Out of the remaining 30 odd numbers, we have to find out another 13 odd numbers. So for that, first we will remove the multiples of 3. Now which are the multiples of 3? For that you need to know the divisibility rule for 3. The divisibility rule for 3 is that if a number needs to be divisible by 3, then the sum of the digits of the number must be divisible by 3. Like we have 111. Now 1 plus 1 plus 1 is 3. So 3 is divisible by 3. So hence 111 will be divisible by 3. So this cannot be the prime number. Now every number you need not add the digits. Which will be the next multiple of 3 after 111? It will be 111 plus 3, that is 114. But 114 is an even number. So if you add 3, then you will get an even number. So what we should do here, we should add 6 to get the next multiple of 3. So 111 plus 6 is 117. Now this is going to be divisible by 3. As 1 plus 1 plus 7 is 9. 9 is divisible by 3. Now 117 plus 6 will be 123, because if you add 3 to 117, then 117 plus 3 will be 120, which is an even number. But we need to check for the odd numbers. So odd plus even is odd. That is why we are adding the second multiple of 3, which is 6. So 117 plus 6 is 123. That cannot be the prime number because 1 plus 2 plus 3 is again 6. 123 plus 6 is 129. Plus 6 is 135. We have already eliminated that. 135 plus 6 is 141. Let us eliminate that. 141 plus 6 is 147. 147 plus 6 is 153. Plus 6, 159. Plus 6, 165. We have eliminated that. Plus 6, 171. Let us eliminate this. Plus 6, 177. We have eliminated. Plus 6, 183. And plus 6 is 189. Plus 6 is 195, which we have already eliminated. And 195 plus 6 is 201, which is greater than 200. Whereas we have to determine the prime numbers between 101 and 200. So we are checking for the divisibility with 2, that we are already done with because we don't need even numbers. 3, we have checked. We are not supposed to check for the divisibility by an even number, so we are not considering even numbers. 5, we have eliminated all the numbers which are divisible by 5. 7, let us take this one. Now, just now I discussed with you that 13 into 7 is 91, which means 14 into 7 will be 98, which means 15 into 7 is 105. So 105 is the first number in hundreds which is divisible by 7. Now this we have already eliminated. Now if you add 7 to this, then odd plus odd shall give you an even number. So what should you do? You should add 14 to this actually, the second multiple of 7, so that odd plus even should give you an odd number. So 105 plus 14 is 119. See, 119 divide by 7 goes by 7, remainder 4, bring 9 down, 49 is divisible by 7. So 119 here cannot be the prime number. Again, to 119 add 14. So it shall be 133. 133 is divisible by 7, so cannot be a prime number. 133 plus 14 is 147, which has already been eliminated here. 147 plus 14 is 161. So let us eliminate that. 161 plus 14 is 175, which has already been eliminated. And 175 plus 14 is 189, which is again a number that has been eliminated. So we have checked for the divisibility by 7. For 9, we know that any number which is divisible by 9 is going to be divisible by 3. For 3, we have already checked. Now that will include all the numbers which are divisible by 9. So 9 is out. Next is 11. Now what is the divisibility rule for 11? We know that the difference between the sum of the alternate digits should either be 0 or a multiple of 11. Now better than that, you know that 11 into 9 is 99, and 99 plus 11 is 110, which is even, and 110 plus 11 is 121, which is 11 square. Now 121 we have already eliminated here. So 121 plus 22, the second multiple of 11, which is even. So 121 plus 22 is 143, which we shall eliminate now. 143 plus 22 is 165, which is a multiple of 5. We have already eliminated that. 165 plus 22 is 187, which we shall eliminate now. And 187 plus 22 is a number which is greater than 200. So let's not consider that. Now you need not check for the divisibility by 13, 17, 19 and all. That's not required. Now we have the other 13 prime numbers. So let's count from the beginning. So we have 1, 2, 3, 4. That is 101, 103, 107, 109. Then 113 is the fifth one. Then 127 is the sixth one. 131 is seventh. 137 is eighth. 139 is ninth. 149 is 10th. 151 is 11th. 157 is 12th. 163 is 13. 167 is 14. 173 is 15. 179 is 16. 181 is 17. And then we have 4 more here. 191, 193, 197, 199. So 17 plus 4, 21 prime numbers, which are given to you here in this box. But this is how you're supposed to find them in case you forget. But they are quite simple to remember. The first 4 and the last 4 should not be a problem. Then 113 has 13 in it. Somehow relate to it that there is only one number in 110s, that is 113, which is a prime number. And 127 is again one number in 120s, which is a prime number. And so on. In 130s, there are 4, then 1, and so on. So somehow you will have to memorize them. And if at all you're not able to, now this is the way that you figure out or find out these prime numbers if required during the examination. But obviously you won't have that much of time, understandably. So the only alternative which is left with you is memorize them. Now what is a square? Square of a number, as most of you know, when a number is multiplied with itself, then it is called the square of the number. That is n into n equals n square. That's how we write it. And cube of a number, when the square of a number is multiplied with the number itself, then it is called the cube of the number. That is, if a number is multiplied with itself 2 times, then in that case we get the cube of the number. As you can see, n is a number. It is multiplied with itself 2 more times, once here and once here. So we get n cube. Or simply n into n square should give us n cube. Now, it's important for you to memorize squares from 1 to 40. Now, most of these you already remember. And this is a table for providing you with the ease of having squares at one place. Now, you do remember all these squares. 1 is 1, 2 is 4, 3 is 9, 4 is 16, and so on. Till 10, it should not be a problem. 11 also is not a problem. 12 is 144. And apart from that, 20 square is 400, then 30 square is 900, 40 square is 1600, and most of you remember that 25 square is 625. So please figure out a way of memorizing these squares. It is a must that you memorize squares from 1 to 40. Now coming on to cubes. You should memorize cubes from 1 to 16. Again, that's quite simple because most of the cubes you already remember. Now, all these cubes are at one place in this table. So 1 is 1, 2 is 8, 3, 27, 4, 64, 5, 125, 6, 2, 16, 7, 3, 43, 8 is 512, 9 is 729, 10 you know is 1000. 11 is 1331, 12 is 1728, 13 is 2197, 14 is 2744, 15 is 3375, and 16 is 4096. Now there is something that you must notice here, and that is there are 4 such numbers in these two tables which are both squares as well as cubes. So a number which is both square and cube, which means it is a square as well as a cube, that means it has to be x power 6. Because x power 6 can be written as x square whole cube, which can be rewritten as x cube whole square. So it's a square as well as a cube. So when x is equal to 1, then you get the value as 1. So 1 is a number which is square of 1 and cube of 1. When you put the value of x as 2, 2 raised to 6 is 64. Now 64 is 8 square and 4 cube. When you put the value of x as 3, you get 3 to the power 6, which is 729. Now 729 is 27 square as well as 9 cube. And when you put the value of x is equal to 4, then 4 raised to 6 is 4096, which is 64 square as well as 16 cube, as you can see here. So please remember these 4 numbers which are of huge importance: 1, 64, 729, and 4096. These 4 numbers are both squares as well as cubes. Now, simple basics of addition, subtraction, very, very simple ones I'll take up here. We know that a positive quantity when added with positive quantity results in a positive quantity. Now, for that we know 5 plus 2 is 7. Both are positive quantities. Now, a positive quantity when added with a negative quantity, the result will either be positive or negative quantity depending on the magnitude of the positive and the negative quantities. If the absolute value of positive quantity is greater than the absolute value of negative quantity, in that case the result is going to be positive. But if the absolute value of positive quantity is lesser than the absolute value of negative quantity, in that case the result will be negative. Now, how is it so? Let's have a look here. 5 plus minus 2. Now that is same as 5 minus 2. So the result is positive, that is 3. But 2 plus minus 5, the result is 2 minus 5, that is minus 3. So this is positive and this is negative. As you can see, the absolute value of minus 5 is 5, which is greater than 2. So whichever out of the 2 digits or numbers is greater, irrespective of positive or negative symbol, finally the result is going to carry the symbol of that value which is greater. Now, when a negative quantity is added with a negative quantity, the result is going to be negative. Let us say minus 5 plus minus 2 will become minus 7. Both are negative quantities added together shall give us a negative quantity. Now let's talk about multiplication part. Two positive quantities when multiplied with each other result in a positive quantity. Example, 5 is a positive quantity multiplied with 2, which is again a positive quantity. We know it gives us 10. Now, when a positive quantity is multiplied with a negative quantity, the result is always negative. For example, 5 when multiplied with minus 2 shall give us minus 10. And when two negative quantities are multiplied with each other, the result is always a positive quantity. Example, minus 5 when multiplied with minus 2 shall give us a positive 10, not a negative 10. So these are the basics which I hope that you people are already well versed with. If not, then I have mentioned them. If you feel that you are weak in such kind of calculations, then first solve at least 5 to 10 questions based on any concept that you feel that you are weak in. Now, that would be a particular exercise to make corrections in your basic fundamentals. Now, let's talk about even and odd quantities here. Now, even plus even or even minus even will always be an even number. Now, for example, 8 plus 4 is 12. So, even plus even is even. And also, 8 minus 4 is 4. So, even minus even shall give us an even quantity. Even plus minus odd is odd. Now, by that I mean 8 plus 5 shall give us a quantity that is 13. Now, 8 here is even and 5 here is odd. So, hence the result obtained, which is 13, is also odd. Now, also 8 minus 5 will also be 3. So, even minus odd is an odd quantity. Odd plus minus odd will always be an even number. So, let us say 7 plus 5 is 12. So, this is odd plus odd. It is giving us an even number here. Also, 7 minus 5 is 2. That is odd minus odd again gives us an even number. Look at the multiplication between them. Even into even will always be even. That is 4 into 8 will give us 32. So, even into even gives us an even quantity. Also, even into odd is even. Now, what does this? Now, what do you learn from here? That if at all, in multiplication of n number of numbers, even if one number is even, the result is going to be even. So, 4 into 7 is 28. So, this is an even number multiplied with an odd number. It gives us an even number as a result. Odd into odd will always be odd. So, an odd number 3 when multiplied with another odd number 5, an odd number 3 multiplied with another odd number 5 shall give us 15, which is again an odd number. So, these are all root basics which you have learned in elementary classes, in fact. Now, let's talk about an important aspect here, that is divisibility rules. Now, some part of that I have already mentioned while calculating prime numbers from 101 to 200. But then let us have a look at the divisibility rules of some of the numbers here. 2. So, when do we say that a number is divisible by 2? The last digit of the number should be 0, 2, 4, 6, or 8. That is, the number has to be divisible by 2. 3. A number is said to be divisible by 3 if the sum of the digits of the number is divisible by 3. So, if you have a number 3, 4, 3, 2. So, 3 plus 4 is 7, plus 3 is 10, plus 2 is 12. So, the sum of the digits works out to be 12. Now, as 12 is divisible by 3, hence this complete number will be divisible by 3. You don't have to literally divide and find out. 4. When do you say that a number is divisible by 4? Now let us assume you have a large number, 10-digit number. Now look at the last two digits, that is the digits in the units place and in the tens place. Now together these two numbers which are there in tens and units place, whatever number they form, if that two-digit number is divisible by 4, or in these two last places if we have two zeros, then the complete 10-digit number will be divisible by 4. I'll give you an example for this. Let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 4. Now, is this number divisible by 4? Look at the last two digits. What is the number formed by the last two digits? 44. Is 44 divisible by 4? Yes, it is. So hence this complete number will be divisible by 4. I'll give you another number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Now, in the last two digits, what do you have? You have two zeros. So hence this complete number will be divisible by 4. For the divisibility rule of 5, if a number needs to be divisible by 5, the last digit of the number, that is the digit in the units place, should either be 5 or 0. So once again, 1, 2, 3, 4, 5. Is it divisible by 5? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Is it divisible by 5? Yes, because the last digit is 0. 6. When do you say that a number is divisible by 6? See, every number which is divisible by both 2 and 3 will be divisible by 6. Now, if a number is divisible by 2, then that number becomes an even number. So in short, we can say all those even numbers which are divisible by 3 will be divisible by 6 as well. 7. Now actually it will be much more faster if you divide the number by 7. But still you have a rule here. Let's have a look at that rule. The result obtained after subtracting twice the last digit from the rest of the number, it should be divisible by 7. Now what does that mean? Let us take up a number here, and that is 343. Now you know that 343 is cube of 7. So anyhow it is going to be divisible. But then let's see by this rule, how do you find that this is divisible by 7? So let's divide this by 7. If you divide this, it will take lesser time, but still I will explain the process to you. Now this is the last digit, that is 3 in the units place. Let's double it. What does it become? When you multiply it with 2, it becomes 6. Now reduce this from the remaining numbers on the left hand side, that is remove the last digit, then whatever is the number formed by the remaining digits, from that you subtract this double of 3, that is 6. So 34 minus 6 is 28. So you know that 28 is 7 into 4. It is divisible by 7, hence this complete number will be divisible by 7. Now you see, if you divide 343 literally by 7, you know that it is not going to take you much time. So that is why this particular rule which has been devised for 7 may not be that effective. Comparatively, you can directly divide by 7 if at all it is required for solving the question. 8. Now the number formed by the last 3 digits should be divisible by 8 or should be 3 zeros. Now what do I mean by that? Now let us say you have a number 1, 2, 3, 4, 5, 6, 4, 8. Now look at the last 3 digits. The number formed by the last 3 digits is 648. Now you know that 64 is divisible by 8. 8 8 is 64. Then 8 is also divisible by 8. So as 648 is divisible by 8, hence this complete number shall be divisible by 8. Now also, if you have a number 1, 2, 3, 4, 0, 0, 0, last 3 digits are 3 zeros, then also this number will be divisible by 8. Now here I would like to address a particular rule or a concept for divisibility rules for powers of 2. Let us say we have 2 power n, alright, and then let us see what is its value. Last n digits. Now the number formed by the last n digits should be divisible by 2 power n. Or if the last n digits consist of zeros. Now 2 power 1, what is the value? Value is 2. Now what is the value of n here? The value of n here is 1. So the last digit should be divisible by 2 or should be 1 0. Now what about 2 power 2? The value is 4. So the divisibility rule for 4. For that, have a look at the power of 2, which is 2. So number formed by the last 2 digits of a number, that should be divisible by 4. That is 2 power n or n zeros. N zeros means 2 zeros. The value of n here is 2. What about 2 power 3? That is 8. We have discussed that. So the last 3 digits, the number that they form should be divisible by 8 or should be 3 zeros. Now it becomes very simple for us to find out the divisibility rule for 2 power 4, which is 16. The value of n here is 4. So the number formed by the last 4 digits of a number should be divisible by 16 or the last 4 digits should be 4 zeros. Now 2 power 5, the value of n here is 5. What is the value of 2 power 5? It is 32. So the last n digits, what is the value of n here? 2 power 5, so the value of n is 5, the power. So last 5 digits, whatever the number that they form, that should be divisible by 32. Then the complete number will be divisible by 32 or n zeros. The value of n here is 5, 2 power 5, right? That is 32. So 5 zeros. Likewise for 64, 6 zeros, and so on. Last 6 digits form a number which is divisible by 64. Then the complete number will be divisible by 64. So anyhow, we move on to the next one. That is now 9. The sum of the digits should be divisible by 9. So if you have a number 1, 2, 3, 0, 5, 7. Now is it divisible by 9? So add these digits. 1 plus 2 is 3, plus 3 is 6, plus 0 is 6, plus 5 is 11, 11 plus 7 is 18. Now since 18 is divisible by 9, now this complete number will be divisible by 9. Now the case is similar to the divisibility rule for 3. Now what was the divisibility rule for 3? The sum of the digits of a number should be divisible by 3. Now similarly for 9, the sum of the digits of the number should be divisible by 9. So the rule for 3 should go like this. 3 power n, let us say 3 power 1, and we have the value here is 3. Now sum of digits should be divisible by 3 power n. So the sum of digits should be divisible by 3. Then the complete number will be divisible by 3. Now what about 3 power 2? We just saw for 9. That is the value of 3 power 2. So the sum of digits should be divisible by 9. Now you can devise a rule for 3 power 3. What is that? 27. What will be the rule for 27? Well, the sum of the digits should be divisible by 27. What about 3 power 4, which is 81? Well, the sum of the digits should be divisible by 81. That's how it goes. So these simple things are very, very helpful while finding out the divisibility rule for larger values. Anyhow, after 9, you have a difficult one, and that is 10. So you know that the last digit should be 0. Then the number will be divisible by 10. 11. Now the difference between the sum of the digits in even places and in the odd places, it should be a multiple of 11 or it should be a 0. Now let me give you an example for this. We have a number 1364. Is it divisible by 11? Let us see. Now 1, 2, 3, 4, these are the positions. So 1 and 3 are odd numbered positions and 2 and 4 are even numbered positions. So first and third number, when you add 1 plus 6, you get 7 as the sum. Now 3 and 4, when you add, that is the numbers in the second and fourth position, even places, again the sum is 7. Now the difference between these two sums, here the sum is 7 when digits in the odd places are added. Here the sum is 7 when the digits in the even places are added. And difference between 7 and 7 is 0. Hence 1364 is divisible by 11. Now let's have a look at another number. 929192. Now is it divisible by 11? Now what will we do? We will add the alternate digits here. So 9 plus 9 plus 9 works out to be 27. Then 2 plus 1 plus 2. 2 plus 1 plus 2 works out to be 5. Now what is the difference between these two? 27 minus 5 is 22, which is divisible by 11. So it can be a multiple of 11. Here, this is a multiple of 11, 22. Hence, 929192 is divisible by 11. Here the difference was 0. So that is why it was divisible by 11. Now this is the way in which you find out whether the given number is divisible by 11 or not. And there have been few questions asked based on divisibility rule of 11 during the CSAT examination, if you look at the previous year papers. 12. When do you say a number is divisible by 12? When the number is divisible by both 3 and 4. Why not 6 and 2? Now, that is where the concept of coprimes will come into play. What are coprimes? We will discuss in a while. But please know this, that the factors, that the pair of factors that you take here, they have to be coprimes. Now, what are coprimes? In short, those numbers which have their HCF as 1. 3 and 4, highest common factor is 1. 6 and 2, highest common factor will be 2. 13, again you can divide the number by 13. Literally, it will take much lesser time if you just want to know. If you just still want to know about the rule, I will give you an example and explain this to you. Now, the number obtained after adding 4 times the last digit of the remaining number should be divisible by 13. Now, let us take an example here. 1, 3, 2, 6, 3, 9. Is this number divisible by 13? Actually, it is, because 13 ones are 13, 13 twos are 26, 13 threes are 39. So you could actually divide this. But if not, then you can still use this rule. I'll teach you how to use this rule. Take the last digit, that is 9. Now take 4 times 9, that is what? 36. Add 36 to this, the remaining number. So what you get now is 13299. Once again, take the last digit, multiply it with 4. What do you get? 36. So 9 plus 6 is 15, 2 plus 3 plus 1 shall be 6. So we get a 1365. Again take the last digit, 5, multiply it with 4. We get a 20. So what do you get? 156. Take the last digit here, 6 into 4. That is 24. 24 plus 15 is 39, which is divisible by 13. So hence the complete number is divisible by 13. For smaller numbers, let us say we take the number 91. Is it divisible by 13? Well, take the last digit, 1, multiply it with 4, add it to the remaining number, add it to 9, which is remaining. So what you get now is a 13, which is obviously divisible by 13. Let's take the case of 169. Now take 4 times 9, it becomes 36. If you add 36 to 16, you get a 52. Now 52 again, you know, is divisible by 13. Or else take 4 times 2, that becomes 8. 8 and 5 again gives you 13, which is divisible by 13. Quite simple, right? But then it will actually save you a lot of time if you simply divide the number by 13. So that is why usually people don't use these rules for 7, 13, 17, and 19. They would prefer to divide the number by these four. Now, number 14. What is the divisibility rule for 14? Even number divisible by 7, or you know that 14 is written as 2 into 7. So any number which is divisible by both 2 and 7. Now any number divisible by 2 will be an even number. So you can say even multiples of 7 will be divisible by 14. 15. Now how do you write 15? 15 is 3 into 5. So any number which is divisible by both 3 and 5 will be divisible by 15. 16, I had already explained to you last 4 digits, because this happens to be 2 to the power 4. So last n digits, that is last 4 digits of the number, should be divisible by 16, or should be 4 zeros. Remember, this is the value of n here. All right. 17, let me just take you through the divisibility rule for 17. Although I would suggest that don't use that rule. But if at all you still feel comfortable, for smaller numbers, you can go ahead and use the rules of 7, 13, and 17, but not for bigger numbers. Now, 5 times the last digit of the number should be subtracted from the remaining number. Then the result should be divisible by 17. Now, let us take a number that is 17, 34, and 51. 1, 7, 3, 4, 5, 1. These are multiples of 17. 17 ones are 17, 17 twos are 34, 17 threes are 51. Quite simple actually. But still, we will take 5 times the last digit, that is 1, and we will subtract it from the remaining number. Now what do you get? 17340. Again, 5 times 0 is going to be 0. So you should get 1734 only. Now 5 times 4 is 20. Reduce that. So you get 153. Now in 153, take 5 times 3 and subtract it from 15, you get a number 0. So hence, this complete number is divisible by 17. Take a smaller number. Let's take 289. Now what is 289? Actually, it is 17 square. But still, let us employ this. 9 into 5 is 45. And 28 minus 45 is minus 17. That also is fine. If you get something which is a negative, that should still be divisible by 17. Or if not, then still you can take 7 into 5, which is 35. Now let's have a look at 18. So every even number that is divisible by 9, because what is 18? 9 into 2 is 18. Why not 6 into 3? I have already explained to you that the pair of factors here has to be co-primes. Now see, 18, how can you write? 1 into 18 is 18. Now 2 into 9, then 3 into 6. Now you can't say that a number is divisible by 18 if it is divisible by 1 and 18. That doesn't make sense. So anyhow, if the same number appears in the pair, we will not accept that pair. So now we are left with 2 pairs, 2 and 9 and 3 and 6. Now the HCF of 2 and 9 is 1 and HCF of 3 and 6 is 3. You have to choose that pair whose HCF is 1 because they are co-primes. And what are co-primes? Which have their HCF as 1. Different types are there. Like the pairs of co-primes could be pairs of prime numbers. See, 13 and 17. Their HCF anyhow is going to be 1 because they are divisible by 1 and itself. Then pairs of prime and a non-multiple of the prime. Now that means that a composite number, like we have 13 and 16. Now 16 is not divisible by 13, right? So these are also co-primes. But if you take 13 and 26, well, the HCF here will be 13 because 26 here is divisible by 13. So this we cannot accept. 13 and 16, 16 is not divisible by 13, hence they are co-primes. Now also know this, that pairs of consecutive numbers, see 25 and 26. And apart from that, any two composite numbers like 25 and 27, even these are coprimes because their HCF is 1. So now using this, you can find out the divisibility rule for any number for that matter. Now what I mean to say here is, if you have to find out the divisibility rule for 24, now how can you say that a number is divisible by 24? Well, factorize this. 1 into 24 obviously is to be ignored because 24 is contained in this. 2 into 12, 3 into 8, and 4 into 6. Now we will take that pair which has its HCF as 1. 2 and 12, HCF is 2. 3 and 8, HCF is 1. 4 and 6, HCF is 2. So a number which is divisible by both 3 and 8 shall be divisible by 24. So whenever a question is asked about a number is divisible by 24 if it is divisible by, and then there would be 4 choices, 3 and 8, 2 and 12, 6 and 4, none of these, whatever. Then this concept of coprimes you have to keep in your mind. Now some important formula here. Sum of initial n natural numbers is n into n plus 1 by 2. Let us say you have to find out the sum of first 5 natural numbers. So 1 plus 2 plus 3 plus 4 plus 5. You know the sum is 15. That is the answer. But rather than doing that, you can simply write it as 5 into 6 by 2. 2 and 6 cancel by 3. So you get 15. What if you have to find out the sum of first 68 natural numbers? Then what do? You cannot keep on adding them up, right? So you will have to use this formula, a simple one. So here we have sigma n equals n into n plus 1 by 2. The sum of squares of n initial natural numbers, that is sigma n square. Kindly remember, it is n into n plus 1 into 2n plus 1 by 6. See, if you had to find out the sum of squares of initial 3 natural numbers, then it would be 1 square plus 2 square plus 3 square. That is 1 plus 4 plus 9. That is 14. That's quite simple, isn't it so? But if you have to find out the sum of squares of initial 20 or 10 or 15 natural numbers, then you please make sure that you use this formula. Now, sum of cubes of n initial natural numbers is n into n plus 1 by 2. That is, this formula has been included here, but this time we will take its square to find out the sum of cubes of initial natural numbers. So if I ask you the sum of cubes of first 3 natural numbers, it will be quite simple. 1 cube plus 2 cube plus 3 cube, that is 1 plus 8 plus 27, which is 36. But what about finding out the sum of cubes of initial 10 natural numbers? Then you need this formula, isn't it so? So how do you apply it in this formula? Well, I asked you about 3. So 3 into 4 by 2 whole square. 4 and 2 cancel. So this is 6 square, which is 36. Quite simple. Now sum of initial n even numbers will be n into n plus 1. See, what was the sum of n natural numbers? Well, it was n into n plus 1 by 2. Now, if you compare with this formula, this 2 should be removed. So you get n into n plus 1 for even numbers. And for odd numbers, it's very, very simple. It's n square. If you want to know the sum of initial 10 odd numbers, it is 10 square, that is 100. Simple as that. You don't have to literally calculate. Now, sum of squares of initial n even numbers. Now, that shall be written as 2n into n plus 1 into 2n plus 1 by 3. Now, you can actually remember it in a very good way. You know that sigma n square, or sum of squares of n natural numbers, is n into n plus 1 into 2n plus 1 by 6. Now, this 6 I can write as 2 into 3. Isn't it so? So let's remove this. Now, this 2, I am taking it here, and 3, I am taking in the denominator. So this becomes 2n n plus 1 2n plus 1 by 3. Simple way of memorizing this. Now, sum of squares of initial n odd numbers is n into 4n square minus 1 divided by 3. So this is something that you need to memorize.